Good morning, Vector friends. I got asked a very basic but very good question. And you know what, guys? You can ask me anything. There's no such thing as it being too stupid there's no such thing. That's how we learn. We ask questions and we work problems. That's how you learn. So if you ask me a question I can't answer, I'll tell you. And I have told many people that they ask me very hard questions. I can't answer them. I try to refer them somewhere else. Okay, the question was when I was showing, we were doing a coordinate transform to spherical, the coordinates. And I plopped a point down here in 3D. I put a vector to that point. That vector turned out to be the radius of a sphere. We're working in spherical, the coordinates, right? And I was showing the basis of vectors in spherical, the coordinates. So let's take an example. Here's ER. This is the ER basis of the vector. These guys won't let me label in this 3D. It's still in demo mode and has been for a long time. Anyway, okay, so get that off there. This vector uh, changing from the North Pole down like this, we're defining this angle as theta. This vector swinging around the equator, we're defining this angle as phi. And of course, the radius is the radius, right? The radius of the sphere. So when I put a basis vector on here, this is the ER basis vector, and I said, what effect does theta have on that? Well, it doesn't have any. Let's take this down a notch. What about phi? And it doesn't have any. What about r? It doesn't have any either. And we'll go through the rest of them as we do them. And the question was, if you look at the equations, why is this not having an effect on the basis vector? So let's go look at that. Okay, here's the equations we derived for the basis vectors ER, E theta, and E phi when they're superimposed on a Cartesian plane. So we have these orthonormal basis vectors EX, EY, EZ. And the question was, well, if you just look at ER, it's clearly a function of theta and phi. And phi is a function of r theta and phi is a function of r theta and phi. So why isn't that changing? It's a good question. Remember the fundamental definition of a vector. It has a direction and it has a magnitude. So you saw when I changed directions using theta and phi, it changed directions with it. But what is this magnitude? How do we do that? Well, it's the square root of all of this squared. Now remember, these are orthonormal basis vectors. So all of the mixed terms, EX times EY, EX, ZY, all of them, they're all zero. The only thing that survives are EX, EY, and EZ. So you just take this, you square each one of these, add them together, take the square root, you get 1. So that's why it's not changing, because it's a unit vector. It's not, its magnitude isn't dependent upon anything, it's a constant. All right. Now let's go look at the others. Okay, let's put the the theta basis vector on here. It looks like that. Okay. Now let's vary theta. Oops, nothing's happening. Let's vary phi. It's changing direction, right? But it's not changing magnitude. What's that tell us? Now let's change the radius. Oh, look at that. It changes with the radius. Now let's go look at the equation. Okay, so to get the magnitude to be theta, we square each one of these, add them together, take the square root. You get r squared under the square root, so it's r. So you saw that it was only changing magnitude with r. It was changing direction with all of these, but it was only changing magnitude with r, exactly as this says it would. Let's look at the very last one. Okay, let's plot the E phi basis vector. There it is. Okay, now let's change the theta. Oop, look at that. It's changing magnitude. What about phi? Nope. No change, just direction. What about radius? Yep, it's changing with radius too. All right, so we had two things. We had phi change the magnitude and r changed magnitude. Let's go look at it. Okay, so here is the e phi basis vector. Square each term, add them together, takes the square root. We get r sine theta, just like we saw. So it was changing magnitude with r, and it was changing magnitude with the theta. Okay, so it's a fundamental question about vectors, and it's a good question. They have direction and they have magnitude. Okay, hope that helps. If it doesn't, answer more. I'll ask more. I'll try. See you later.